What I'm going to do today is a kind of a quick live demo. Live demos are kind of fraught with disaster. So I've worn my lucky Bill Murray t-shirt. Hopefully everything is going to go fine. What I want to do is just kind of show you how you can automate installations, configuration with EOS. For us, what we've been concentrating on for the last month is trying to get more people into EOS. I mean, the more people that can run EOS nodes, the better for the network. You know, whether you're a dApp developer, if you're creating a smart contract with custom actions, you're probably going to want to run your own local node to ensure that those actions are indexed from the beginning. It may be that you're just an EOS enthusiast. You want to learn more about how the chain works and you just want to spin up a node. Or maybe you're a budding block producer and you want to get started quick and kind of learn from the people that have been around for the last 6 to 12 months. So what I'll do is just share my screen here. Okay, and hopefully you can see my window. So just a quick bit of background. My name's Pete. We're from BlockMatrix. So we're an EOS block producer. We've been involved in the community now for maybe the last 6, 7 months. So, participated in the early days on the Crypto Lions Jungle testnet. We've all learned a hell of a lot together. My background is in online advertising. So back in my fiat mining days, my responsibility was developing software and creating infrastructure to handle billions of things. So had a good amount of experience with creating infrastructure that can handle a lot of scale. And what we've tried to do is put some of the learnings from those days into the infrastructure that we've put down to support the EOS network. So what I'm going to try to do today is just show you, by using a tool called Ansible, how we can actually create and configure a node to run the EOS mainnet in just 2 commands on the terminal. So hopefully this will go smoothly. Everything that I show you is backed up in our GitHub repo. I'll confirm the URL later. So you could just run this yourself. And again, I'm just going to do this on 2 throwaway DigitalOcean nodes. So you don't need any infrastructure at hand. This can be done on both cloud infrastructure and bare metal. So what is Ansible? It's part of the configuration management tool set. You may have heard of other like tools of Chef and Puppet. For us, when we're picking tooling, it absolutely has to be open source, which Ansible is. It needs minimal dependencies. So if we're going to be installing software on nodes, we don't want to have to install a bunch of boilerplate on those servers. We certainly don't want to have any agents, so any kind of daemons that have to run to listen out whether something to be installed. And the tool needs to use open standards because it's got to be easy for people to pick up and get running with it, especially as we expand our team. Within Ansible, there's 2 file types. It uses YAML, so it's human readable and it's machine readable. And effectively, all of the YAML documents, they're read in chronological order, so from top to bottom. So the commands that you put at the top will be run first. If any of them fail, all of the commands below will not execute. Now, the beauty of the way that Ansible has architected this is that they've brought in programmatic concepts into the YAML file declarations. So we can use variables. So you can see this item variable here. And we can also use loops, dits, arrays. So this just allows us to bring these programming concepts into our kind of declarations for when we're describing what should be installed onto a server. The second file type is Ginger templates. This is kind of more for storing your configuration files. Maybe you have some scripts that you want to copy up to servers. And again, we can use variables and loops in here, which in the case of EOS is super useful. So we can dynamically inject peers that we want to connect to. And we can do this on a per node basis. So it may be that for an API node versus a seed or a producing node, we want to have a different set of peers that we connect to. We're probably going to have different server addresses, IPs, etc. We can handle all of this transparently thanks to variables and loops. And really, how does this look conceptually? Well, you have what's called a management node or a control machine. And that could just be your laptop, or it could be an isolated server that just purely runs Ansible scripts. And it can contact one-to-many servers. So, in your cluster, you might have 2 or 50 machines. That's no problem for Ansible. You maintain what's called an inventory. And into that inventory, you can classify and categorize a bunch of servers and roles and attach variables and whatever to those. So it's super dynamic and allows you to manage small to large infrastructures from a single control machine. It's pretty awesome. So enough of me chatting. Let's actually go and try a demo. So what I'm going to do here is, let me bring up my terminal. In my top left window here and my top right, this is my control machine. So this is just my local Mac. And what I'm going to do on the left-hand side is actually install EOS onto this remote server here on the bottom left. And then once it's installed, I'm going to actually configure that node for the mainnet. So we can actually just start a node and it'll begin syncing. Now, the actual installation of EOS, because there's a bunch of stuff to compile, takes about an hour. So that would be a very long and boring presentation if I just made you wait for that. So what I'm going to do is set it off and just show you the output from Ansible. And then I've prepared a node earlier, which I'll then show you how the mainnet is installed. So what I'm going to do is execute this command. So this is a playbook. So a playbook is basically a concept within Ansible that defines everything that you want to do. And then you can pass in a host to tell it where to actually execute this. So I'm going to execute it. And what this will do is go and fetch the IP address for our host, API1, and then just work through the playbook. So let's actually have a look through that playbook. And what we can see here, remember it's top to bottom. So what this is doing now is creating an EOS directory. It's then cloning the EOS repository. And you can see here we have a variable for the link to the repository. So this would allow you to use either the official repo or the community maintained repo. And then there's a version tag here too, because there's upgrades all the time. So we want to be able to cleanly upgrade all of our servers. Again, there's a variable for that. Then as we scroll down, here is the command where the actual build process happens. So thankfully, within the EOS repo, they bundle a nice shell script that will take care of installing all of the dependencies that the EOS project requires. And then we do a few other kind of housekeeping exercises here, where we're basically just linking the binaries. So we always have access to the latest versions of the Node EOS binary, CLEOS, etc. And then quite important, it's very, very essential that on all of the Node servers that we have a good sync for time against the atomic clock. So this will just basically ensure that we install NTP always and have that synced with the atomic clock. So if we flick back, we can now see that within the server, it is cloning that repo. So let's just have a little look here. And we can see actually the EOS directory is there now and being created. It's now cloned, grabbing the submodules, and now the kind of long build process is starting. So on the right-hand side, let's now actually configure the mainnet. So on the top right is my local machine, and the bottom right is a remote node. If we just have a look what's in this directory, we have a testnet in there. We have previously installed EOS, but no mainnet. So let's kick that off. And what we'll do is have a look through that playbook. So one of the things I wanted to show you, and just how you can configure either a mainnet or a testnet. We have a config file here, which is the config ini that the node EOS process uses. And here we can define, again, we're just using variables to say who we are, what is our HTTP port, what P2P port do we use, where it should look for its blocks directory for its data of the chain, and then we have a bunch more options here. So again, this is all up on our GitHub, and it would be great to kind of support more nets. We could, there's obviously the Crypto Lions Jungle testnet, there's Cheyne. Very easy just to put up a configuration for each of those. But let's have a look what this is doing. So basically it's saying check that Kleos is actually installed. So it's just a very simple check to see that we actually have installed EOS on this machine. Then copy some files, create this mainnet directory, and copy our config ini. So if we flip back to our machine now, and we have a look, we now have a mainnet directory there. And here we go. Essentially, that is it. We now have a machine configured for the mainnet with a custom config ini that's relevant to our settings, and there's some helper files in here that will just kickstart the mainnet. So it's as easy as that. For us, we really want to cultivate a thriving developer ecosystem around EOS. It's such an amazing project. The protocol there is, just ready and waiting for a bunch of amazing things to be built on top of it. And we just want to make it more accessible for everyone to get on board. We created a microsite called eosnode.tools, and every day we push up a backup of our local chain state, so the blocks directory. You can copy this down to a node, and it just allows you to sync with the chain much faster. So now even compressed, you're looking at 16.5 gig for the blocks directory. That'll take a long time to sync from the beginning if you do this just purely from the chain. So you can use this just to basically get up to speed faster and sync with the network quicker.
Hey, thank you. That was awesome. That was awesome. Cool. Yeah. It's actually really helpful for people from outside to see the node running like that easily, just like you did.
Yeah, absolutely. It's it can be a bit daunting to kind of get started, but actually the beauty with automation is it self-documents. Yeah. So you can kind of put all of the learnings of the last 6 months into 2 YAML files, and you can just get kick-started.
That's really educational, seriously. And we have one question from Santosh. Does Ansible also capture std error or stood out, so you can see if something went wrong?
Yes, absolutely. So you can capture both of those on any command and relay it based on success or failure. So it's extremely useful. Rather than just see a red line to say something failed, you can capture what the actual output was on the host machine and relay that back to your control machine.
Oh, okay. Does that answer your question, Santosh? Yeah, it should be. It should be. Okay. Do we have any other questions? Okay, I think. And people are applauding. Great tool, great tool.
Thank you all.
Yeah, thank you, Pete, for participating here.
No problem. It was awesome. Thanks for organizing.
Yeah, and
See you later.
I'll see you around.
Absolutely.
Yeah, thank you.